Alright, welcome. This is the first in what I plan on being a series of videos where I'm going to put the new Traveler World Builder's Handbook for Mongoose through its paces. I've done a previous video with an overall review, but now I'm going to leverage this resource for my solo scout campaign I'm playing here. I'm currently playing the ISS Intrepid S-Class Scout with our crew. Had some interesting experiences here in a place called Kotari. Ran into another alien actual empire. So had some interactions with the ISS Endeavor, which I believe is involved with Imperial or even Scout intelligence. Don't know at this point, but our Intrepid got orders after this first contact not to return to the Scout base, but to continue their survey down this arm here. So previously they were able to jump from here before the Surin defense boat or patrol craft got too annoyed and told them to stop. So they got into it, and they've had a pretty much uneventful jump. They nailed it. So now they're in the system here, and we're going to work through the survey guidelines here in this World Builder's Handbook. So that's where we're at right now. So I've kind of been through this already a few times. You've seen my previous review, but I think let's start. This is what I saw as I go through it. First table here is the survey classes. This is a good starting point. Pretty much defines what different types of surveys they are. From a class 1, which is a remote survey. Remote survey from about 1 or 2 parsecs away. Could have been from here even. That's 2 parsecs, so it could have been from the scout base. That's fine. There actually is a class 0, and they unpack that. I'll show you in the back a class 0 and a class 1 survey. Simple format, class 2 and 3. You're starting to be in system here. And that's what we'll do next. Locate all significant planets, moons, planetoids, and they even give a duration here, about a week. Then class 3, determine orbits, physical characteristics of all major bodies, deploy landing parties. 10 weeks, up to 10 weeks. Probably this will be as far as I go, depending on what they find here in their survey. But then there is the 4 most, kind of 30 weeks more exhaustive, and then 5 is, you've been there 5 or 10 years. Examine major worlds in detail, long-term client effects, contact natives, okay? So this is a good guideline here to drive the actions of the survey. And then they do come up with this concept of survey index. Survey index applies to a system saying, hey, what's the level of surveying done? 0 is no data. 1, actually we're going to be doing, in today's video, we're going to be doing a kind of combined class 0, class 1. So when we're done, we'll have this system up to a survey index of 5. Presence and type of stars, presence of some bodies, gas giant or larger size. So that's our goal here. And I could just roll right into here, and then they talk about in detail, figure out the primary star, and here's a big table we're going to use in a second. Let's figure out first the primary star type. Now, what they do give you also at the end, and I pointed this out in the last video, is, let me find it here. I've got this clipped, but it's probably better to come here and look. Yeah, here we go. And this isn't very quick, so it's not like you're cutting any corners here. Quick survey guide for exploration adventures. Using a few dice, unknown system can at least get through the class 0. So this is a quick way, I guess, if you wanted to go and get this. And what you're basically identifying is the primary star and any additional stars, and is there a gas giant or gas giants present, okay? So again, this is kind of a quick way to do a class 0, so you could potentially like roll through all of this and get this information for all these systems, maybe to make the decision of whether it's even worthwhile to visit. So I kind of use this to do my initial, and there's forms here. We'll show them later, but I converted their forms into somewhat of an Excel spreadsheet so I can record this stuff. So did some things also. I finally named this subsector. Don't know where I got that word, but I call it the Cami Marches. Cami Marches. That's the whole subsector, and then we're looking at 0607, which again, doing random generation. I think I got it on a website. Multiple sources of that. I end up with the name of the Carovin System. And the primary is probably going to be called Carovin. So get some initial information here. I'll tag this later. Yeah, I got names here too. So I did that. So if we do this, and they say the first 3 steps can be Yahtzee-like. Okay, using different colored die. I just did step 1, 2, 3. So the first thing we do is primary star for each hex with a system roll 2D on the star determination table and record the star's primary type. Now I'm not going to leave this up. I do have this on another screen. I'm going to come back to the tables now. And yeah, we're not there. We're doing stars here. Yeah, here's a form actually. This is a class 0 form. Yep. So you do see I attempted to got to flip this, but converted this, and here's a class 1 form. So that's our goal here, to fill this out for the system. So let's come back up here to that first table. Its distances, multiple stars, luminosity, primary star type. Determine the type of primary star, roll 2D, and consult the type column here. Most stars will be class 5 main sequence. This is the default assumption. So that's what I'm going to assume, because we're not rolling on the class. So class V main sequence is what I'm going to assume. So first thing I did was, when we come over here and I've recorded my rolls, 2D6 I actually got a 6, 5 and a 1. So if you go to 6, we're an M class star, and we'll unpack that when I found out I'm learning stellar cartography, whatever it's called. This is mainly in the infrared. It's not very bright. So that's interesting there. So we put in here, it's an M-type class 5. We're filling out the form here. Now the next big roll, and there's other things that can happen. You roll a 2, you're on the special table, which then changes the class now. You roll a 12, you're on the hot table. This I don't know yet. I haven't figured this out yet here. I don't know if you pick this or whatever, if I've got a peculiar protostar. I haven't quite figured that one out. Special systems, you know, I don't know yet. Well, giants goes here. Unusual, well, here's peculiar, can go here. So my guess is special, and then you roll unusual, and then he can go to there. Either way, I got an M type. I think Sol is a G type, R star. And second roll in the type column, DM +1. Okay, and then they got some different realities here. Okay, go through here. They got an optional variant. It's kind of biased, they're saying, so you could change it. 3 to 8 is an M. Take, you know, move the K's back. 9 is a K, 10 is a G. And then they do go into peculiar star types, subtypes, etc. Now the next thing we had to figure out, well, the next thing we had to figure out was, are there more stars? And this one I was a bit concerned about, because you can get a lot of stars here. So actually, I mean, here it is, multiple stars. And what you do to figure out if there's multiple stars, you know, just not one, is you roll on what's called a presence, and you roll in the close, near, and far. And then if you end up with a star in either of these positions, you roll again for each one to see if they have a companion in orbit. Now 2d6, 10 plus, and then you do have some modifiers here. So like in our case, class 5, type M, we would have had a DM -1. we would have had to roll an 11 or a 12. Okay. Luckily, in my case, I didn't come up with any, but what I did use was, I don't know why I'm speaking in the plural here. They had a shortened version of that. Instead of doing the 10 plus other stars, use a modified version of the multiple stars presence table. A roll of 10 plus on 2D is equivalent to a roll of 6 on 1D. Okay, great. Therefore, roll 4 dice. Every 6 is another star in close, near, far, or companion to the primary. For primary stars with a DM -1, multiple stars, ignore every other 6. Okay, so that's how you kind of incorporated that DM -1. That's fine. I rolled the 4 dice, and it was irrelevant because I didn't get a 6 on any of them, which kind of breathed a sigh of relief because this is kind of like our system. It's only got 1 star. So I could put NA in all of these, okay? Now the last thing I had to do is, hey, this just doesn't say how many gas giants, but it says, is there a gas giant present? Now I knew from my previous generation there was, but I went ahead and rolled it. Roll 1D, and as long as you don't roll a 1, the answer is yes. And the answer was yes. So we do see here, there's your class 0 review. And then they say determine the other types of star. That doesn't apply. And then if the travelers decide to jump to the star system, now we can do a class 1 survey, subtyping, system age, which we're going to do here, etc. And then if you're just passing through, all you care about is there's a gas giant source of fuel. And maybe there's a habitable world. Okay, and this is an abbreviated way. We're going to unpack this when we get into the class 2 survey. But let's go ahead and see me finishing out the rest of this form here, going into the class 1 realm. And got to answer a number of other questions here. And not having more than 1 star made things a bit easier, which is good for my first one here. So the next question we answer is mass and temperature, I'm pretty sure. Yeah, oh, first subtype. So this is a straight, again, 2d6, either using the numeric column or the M-type primary, and that's us. I got an M-type, and it's a primary, so I use this instead of this, all right? So for my subtype, I rolled a 6. I thought, wow, that's the same thing I got here, which, of course, for a 6, I'm over here at a class 0, okay? So my full name for this star now is an M05 main sequence, and I think M0 is on the big side. So I record that, and this is good. They have this example. This has helpful here. So now I've got to figure out the star mass and temperature. Now there's no rolling here. What you do is you take your star type here, which M class and 0, I actually have an entry here. If you've got something in between, like M0 and K5, they talk about how you kind of estimate it from the difference here, okay? But looking at I get a complete match on M0, I can come across, and I'm class 5, which tells me I've got mass of half of our sun, 0.5. Everything is in reference to our sun. And then it talks about what's the temperature, 3,700 Kelvin, which our sun, we find out later, is 5,600 Kelvin. So this is going to be cooler. And actually it's orange-red. That's the color. Okay. So here we've got the mass and temperature now. So it's half the size of our sun, cooler. And we're going to see soon, not very bright. From a luminosity point of view. Next question we ask is the star diameter, which affects its luminosity. Okay. So looking at that, let's see, we figure this out. And then how bright is it? So let's do star diameter. Luckily, again, I've got M0 here. I don't have to interpolate. And I come to my class and I just pick main sequence. So my diameter is 0.7 that of our sun. So half the mass and only 0.7 in the diameter. And this is important from the point of view of also, where's the jump point, how far out. Okay, so now we've got the diameter of 0.7. Okay, this is a nice little thing. The M class looks like this. 2400 to 3700, I think with an M0 we topped out. But we're going to see in the luminosity, here we go. Again, we've got an M0. My class is 5. Oh my gosh. 8% the luminosity of our sun. That's pretty dark, okay? And if you read somewhere in here, they talk about the different star types. M types, much of their energy is in the infrared. Okay, not visible, so it's going to be dark. It's going to be cold. The habitable zone is probably going to be real close for the planets here. So great. And then they also have a formula, and I went ahead and ran the formula too, and it worked. I mean, the formula pretty much gave 0.08. So, you have an option, use the chart, use the formula. Straightforward. What's the diameter? And whenever you see this, the reference point of Sol. So this is pretty much 0.7 over 1. So 0.7 squared times the temperature. In our case, it was 3700 over Sol's temperature, 5772, to the fourth power, and then multiply the two together. You can see it gets really small because it's under 1, and it actually came out 0.08. So the formula worked. And again, as usual, here's an example. So infrared, not very bright. Another entry here is what orbit. If I had multiple stars, I'd have to unpack that and figure out what stars at what orbit and companion, etc. There's a whole bunch of calculations. But I didn't have to do that. So the next thing we did was the age of the system. This was an interesting one, main sequence lifespan. So how long will the star remain in main sequence before it starts consuming itself, I guess? And I ran that number. It's 10 over the mass to 2.5. Look, we have a 0.7 mass. So we did 0.7 to 2.5 power with 10 over it. And I ended up with 55 gigayears, which is a long-lasting star. Let's see, mass is for 10 billion years. I think a giga means a billion. So it's going to be in the main sequence for 55 billion years. And let's figure out how far along it is in that process, randomly determine it. Roll 1d, multiply by 2, then roll d3 minus 1, add that value to the first, and that's the sum in billions of years. And when I did all that, it's roughly 7 gigayear into main sequence. So this star is going to be around for a while. And then there's a formula too, and again, I came out close. Yeah, there you can see I did the formula. And it came out, well, that's not the formula, that's a 1d6. That's a summary. Okay, there we go. So that came out, and then they have different ones for small and large. And then they go into the different unique class of stars, but ours will be here for a while. So looking back at the chart, I don't think I really had much else to do for this class 1. That's all special stuff. Dodged this bullet for this one. Doesn't mean in the next one I won't have that. And this goes into location of stars, orbits, etc. And then how you designate the stars, But ours is very simple. It's the A star. There's only one, and it's in orbit 0. So that was good. And then they go into the different orbits, ranges, stars, is it a near, close, etc. Fractional orbits, pretty detailed. Again, eccentricity and their rotation. Since I only have one star, I don't have to do any of that. Stellar classes and types for multi-stars, age adjustment, orbit period. And then they talk about you can reduce now the star to a star system profile. For the Z system, the example they did, it had a bunch of secondary stars, so kind of get this really long one here, but it's G7V, G8V. In the end, it amounted to 3 stars, so they show you different ways to record it if you want to do a profile, kind of like the world profile that's done in the main traveler. And then they end each of these sections with procedural point of view from the Scout survey system. And they talk about the survey here. Class 0 surveys, armchair surveys, great distance using arrays of telescope, historical chart starts, some 10,000 years old. Then they get into how it's disseminated to the public, etc. And then the Class 1 survey, determine orbital characteristics of stars and planetary objects. Massive observatory equipped Scout survey cruiser from 30 parsecs. Or here we go, our Armstrong or Adonasev, or I would, let's. At this point, I can probably say the Scout base did this preliminary stuff for us because it's only 2 parsecs away. And now we have a 0-1 done here. So we're ready to move. So the interesting things I get out of this is, in my mind, the biggest thing is it's not very bright at all. It's mainly in the infrared, which kind of reduces the chances of, necessarily finding life. I would guess that they're familiar with. So, and it's in the red-orange range, and it's the only star in the system. Okay, so we could say this was the 0-1 sector survey provided to them by the Scout base, who's probably done a 0-1 of survey 0-1 from a distance. This is pushing it, but they can definitely do this one. Okay, so this is the initial information coming in. So the next thing to do, and then they end up, here's the forms, and then they give examples of the systems. They do 3 systems through this. Here's the Z system, and you actually see, if I'm reading this right, 5 stars. And then they get into mass and temp of all of them. They have another system, Corella, they're looking. Home of the Corellian League, and it looks like 2 stars. And then they just throw our sun in. Notice it's only got 1 entry. And it, mass is 1 because it's the reference, diameter is 1. Luminosity is 1 because our star is the reference here. And here's that temperature they mentioned. I haven't calculated this yet, but this is a habitable zone. And like I said, with the star here, my guess and the temperature, the habitable zone is going to be closer. This actually is the orbit number. We're Mercury, Venus, Earth. That's why it's a 3. So my guess is it's going to be a lot closer in for this one. So with that said, the next big thing I'm going to do, the next big video, and this is the biggest section of the surveys, I'm going to move into the Class 2 survey, where we actually map out the system worlds and orbits. And I'm going to leverage, go ahead and leverage what I've already got here from the initial survey doing the continuation method. So anyway, that's it's 23 minutes. So again, that's going through here. The bullet I dodged was it didn't have more than 1 star. This would have been a bit more complex if I had more than 1 star and I had to figure out the details of the stars, these secondary stars, placements, companions, and all the other details. But yeah, pretty straightforward, starting to get a feel for the system. So in the next video, we will plunge into working through a Class 2 survey of the system. Let me see what that looks like here. Yeah, this is really long. Planetary system. Yeah, here we go. Here's what a Class 2-3 survey form looks like. And it looks like here are the planets with notes. Object orbit number, eccentricity, period, the year. I'm going to decode what those are in a second. Notice this is the information gathered from before. So next we're going to define this here. This survey in the Class 2 takes a week or 2. And if we do identify that the primary world is worth surveying, We're probably going to come in first, and part of the determination number of gas giants, we're going to try and take a shot at refueling before we then proceed to the habitable world and start going into more depth, probably the class 4 survey. And what I find interesting is there is a component that you can calculate whether there's native life anymore and whether it's sentient. So we'll see. And there's going to be some random tables to try and figure out too if this has already been claimed by the CERN Empire. Don't know about that either. So there's some questions ahead, but here's our base survey, class 01, and it's time for our crew to do what they're trained to do and start hopefully what we call a typical bread and butter full system survey with just a chance out test out this new World Builder's Handbook from Mongoose and see how it works. So I'll go ahead and end it here. Thanks for listening. If you liked, click like. Any comments appreciated. And if you haven't subscribed yet, that would be awesome. Otherwise, see you at our next survey video.